But how do we know that this is actually true? Yes, we will have to prove it. How though? Just like what I mentioned earlier, the epsilon-delta definition. Okay, here's the deal. If we have the limit as x approaching some number a of some function f of x, if we do end up with some limit that's called to be L, this right here means, you ready? It's mean, I know, but it means for all epsilon greater than 0, there exists a delta greater than 0 such that if the distance between x and a is small enough, and for distance, it means we have the absolute value and they just subtract them. So we put absolute value of x minus a. If it's small enough, how small is small? Less than delta, okay? And then we do not need x, we do not want x to be a, so we want to say this is greater than 0. If this is true, then we must have the absolute value of the, well, it's pretty much the distance between f of x and the limit L. It's small enough as well. But in this case, we write it as f of x minus L to be less than epsilon. Yeah, here we go. How do we write proof? Write down P at first. Everybody will be happy. Forwards. That's going to make everything much clear, systematic, easy to follow. First word, given. Why? When you see for all, right? Just start the proof by saying given. And you can just say given epsilon greater than 0. And some people might say, you should say let epsilon be greater than 0 like this, and then be arbitrary. That's cool too, you know. If you say something like this, you sound more like a mathematician. And if you write given epsilon greater than 0, that's short and concise, and the people wouldn't get mad at you. So either way, but given, I think it's okay. Next, you see that right here it says there exists. So to show that there exists, you are going to pick, you are going to select, you are going to choose. I like to use the word choose. So that means you can show that, hey, we do have such a delta. We are going to choose delta, but delta is what? We don't know yet. Just leave it blank for now. A lot of students get stuck with epsilon delta definitions because they just don't know what delta is, and then they're stuck. I'm telling you, don't worry. Just write it down, leave it blank for now, and then we'll come back to it later. Okay? Okay, such that we are going to assume that we have this. So I'm just going to say suppose. If you would like, you can also say assume, but suppose. Suppose this is true, meaning that the absolute value, and here we have x minus 1, right? X minus 1, because this is x minus a, so it's x minus 1. Suppose the distance between x and 1 is small, meaning less than delta, but we don't want x to be 1, okay? So we put this greater than 0 when you read it backwards. Because of this, that's why 5 hours ago, when we saw the graph, you see, we don't care when x is exactly 2 or 3. We don't care because we have this inequality. Yeah. Anyway, we suppose we have this condition. With that, we hope to show this is true. And we hope to show, that means we better do the check. So we are going to check. Or you can also say, we see, put we see here, and then just go ahead and do the computations and all that. But anyway, we check. Check what? The absolute value, our function is 6x minus 2. And then minus the L, which is 4. Okay? Function minus L. And then we hope to show that this right here is going to be less than epsilon. Okay, so this is the general framework. Now, this is the part that we will have to do the most amount of work, and then just do some algebra first. Minus 2 minus 4 is minus 6. And we can also factor out the 6 on the outside. So perhaps I'll show you guys like this, 6x minus 6, and then factor out the 6. And then we get x minus 1. Okay? And this is great because you see how we have the x minus 1 in the absolute value. We know that right here, we have this. Absolute value of x minus 1 is less than delta. So we can say that this right here is less than delta. We replace this absolute value with less than delta, but we still have the 6 at the front. So you see, we create this inequality, the less than that we want. Very nice. But keep in mind though, at the end, we want to end up with what? We want to end up with just epsilon. We just want to end up with epsilon. So what do we need? Well, check this out. This right here is 6. 6 times what will give us epsilon? Well, it's just epsilon over 6, isn't it? Because when we have that, check this out. 6 and 6 cancel, and then we get the epsilon. Cool, huh? So, once we figure this out, you see, delta is just epsilon over 6. We rush back to here, and then let's write down epsilon over 6. And you see, because epsilon is greater than 0 and over 6 is still greater than 0, so if you would like, you can indicate that, but nobody really does that. But just want to say delta is greater than 0, okay? And a few things though. You see how we pick delta to be equal to epsilon over 6. So right here, I'm going to put on equal sign. Delta is equal to epsilon over 6. And I cancel. So after the simplification, this right here is still equal. But the way that you read this is that we have this inequality, which is equal to this, which is equal to that, and then this is less than this. And this is equal to that, is equal to that. In other words, this absolute value is less than epsilon. So we are done. Put box. Yay. Okay, and then to do this, you can just do this in your head. Negative 2 here, 2 times negative 2 is negative 4 plus 7 is 3. So this right here is equal to 3. Done. Now, epsilon delta definition means if we have the limit and if x is approaching a, if we have a function f of x, if this right here give us a limit, let's call it L. This right here means, where's the n, huh? This right here means, here we go. For all epsilon greater than 0, there exists a delta greater than 0 such that if the distance between x and a is less than delta but bigger than 0, so we write it as absolute value of x minus a is less than delta, but we don't want x to be a, so we put greater than 0. This right here implies, that's the symbol for implies that the distance between f of x and L is less than epsilon. So we write f of x minus L is less than epsilon. So just go ahead and write down a few more times and then watch the video where I showed you guys an actual example with picture, with number, and then you will see that it's like the epsilon stands for error, that's why it's E epsilon. It's kind of like it squeeze the, just like kind of make the function as close to the limit as possible, that kind of thing. All right, so now here we go. What's the first thing? Yes, PF. Okay, for all, go ahead and write down given epsilon greater than 0. Next, there exists, so we are going to write down choose delta. Delta is what? I don't know yet. Don't worry, leave it. We'll come back to it later. Then we are going to assume we have this condition. So I'm going to suppose. So given suppose, given choose suppose, and then check. Suppose the absolute value, here we have x, and then minus a, which is negative 2, so it becomes plus 2. Suppose this right here is less than delta, which we also don't want x to be negative 2, so that's why you have the greater than 0, and then check absolute value of the function minus the limit. So this minus that in the absolute value, 2x plus 7 and then minus 3. Alright, given choose suppose check. Given choose suppose check. Now, focus on this and do the algebra. 7 minus 3 is 4, and then we can actually factor out 2. So let's just go ahead and factor that out. It should be okay. And then we end up with what? X plus 2. Absolute value of x plus 2. So good, because look back, this right here we know is less than delta, and then we have a 2 in the front. Yeah. Now, keep in mind, we want to end up with epsilon. So we have 2 already. 2 times 4 will give us epsilon. We better have epsilon over 2, because this way, this 2 and that 2 cancel. So we know we should choose delta to be epsilon over 2. And of course, epsilon is positive, over 2 is still positive, so it satisfies it. And because delta is epsilon over 2, so we put equal. Likewise, this is just simplification. We put equal sign, and then we're done. Done. Epsilon greater than 0. Next, we are going to choose what? Choose delta to be what? Don't know. Leave it. Then suppose the distance between x and 3. So we say x minus 3. We want this to be less than delta, and we don't want x to be 3. So put a greater than 0. Like looking at backwards. Then we check absolute value of the function minus the limit. So we are looking at 2 over 3x minus 5 minus negative 3. So it becomes plus 3. Okay, here we go. We have a fraction. So let's see how it goes. Okay, negative 5 plus 3 is negative 2. So here we have 2 over 3x minus 2. Okay. Can we factor it? Yes. We can still factor out the 2 over 3. Check this out. So I break this up, so it's x. And then we have the minus. But originally, here is minus 2. We factor out the 2 over 3. So what should we do? We should look at this and divide it by. We should just look at this divided by that. Divided by 2 over 3 is the same as multiplied by 3 over 2. They cancel, so we just have just a 3. I'm not kidding. Check this out. Distribute back, we get this. This times that 3 cancels, 2 minus, yeah. What's this? Less than delta. So we know this right here is 2 over 3 times delta. And at the end, we want this to be equal to epsilon, right? So you know it. Delta should be equal to what? Well, this right here, we will have to kind of work it out a little bit. 3 over 2 times, okay, we want to have a epsilon here, and then perhaps we just need a reciprocal, right? Namely, 3 over 2, because this way, 2 and 2 cancel, 3 and 3 cancel, perfect. So that means delta is equal to 3 over 2 epsilon. Yeah. This is equal to that. Put it there. Done. Yeah. Take a limit as x approaching 4, and then we have the square root of x. Man, this, if it's a computational question, is super easy, huh? Because the answer is just 2. Yeah. But for proof, let's just go ahead and do it. PF. Here we go. Given epsilon greater than 0. Next, we are going to choose delta. I don't know, just leave it. Then suppose what? Absolute value of x minus 4 to be less than delta, and then greater than 0. Look it backwards. And then lastly, we check absolute value function minus the limit. Okay, that's all we have. All right, now we cannot factor this anymore, huh? But don't worry, we did a lot of this example before. When we have square roots, what did we do today? The conjugate. So let's go ahead and do that. I'm going to just write it down right here. I'm going to have square root of x minus, let me write it down like this. Square root of x minus 2, right? And then I'm going to multiply the top and bottom by square root of x plus 2, and then over square root of x plus 2. Aha! Yeah? And then you see this right here will give us just x on the top. And then minus 4, right? So it's that over square root of x plus 2. When we have an absolute value of a quotient, this right here is the same as the quotient of the absolute value, meaning that we can look at this and say this is just the absolute value of x minus 4, and then over absolute value of square root of x plus 2. But the thing is that the output of square root is always positive. Likewise, when we add a 2 to it, it's always positive. So this square root on the bottom doesn't matter. You can erase that. Good. And then you see right here, this is the place that we can use the less than delta, which is yay. But what exactly do we do with the bottom though? We have square root of x plus 2. This right here is actually just equal to, this right here is actually just less than absolute value of x minus 4. Just get rid of it. Why? I'm going to give you guys an explanation. Because square root of x plus 2 is always greater than 1. I'm not saying the bottom is always positive. I'm saying that the bottom is always greater than 1. That's why when I get rid of this, right, this right here is smaller than just the top. Let me give you an example to convince you guys. So suppose you have 8 versus 8. Of course they are the same. But if today you have 8 and then divided by 2, then it becomes what? This right here becomes smaller than that, right? Yeah. However, if you have 8 divided by, let's say, a number that's positive, but it's 0.5 compared to 8, which one's bigger? This is bigger now. Yeah. If you divide it by 1, they are equal. If you divide it by a number that's bigger than 1, then this right here will be smaller than this. That's why I'm mentioning square root of x plus 2 is bigger than 1. So I can legitimately get rid of the bottom and then just say this is less than just the top. So this is the idea. So that's really good, because now when we have just the absolute value of x minus 4, we can say this right here is less than delta. Now we can say this is less than delta. Yeah, and then what exactly do we want at the end? We just want this to be less than epsilon, right? So we want the whole thing right here to be like epsilon. So what do we want? We want delta to be equal to epsilon. So we rush back here and just say delta is the same as epsilon, and we are done. And we are done. Now prove it. Pf given epsilon greater than 0. Next, we are going to choose delta. I don't know yet, so leave it. Then we are going to suppose, okay, and then we have x minus 6, so just go ahead and put that in the absolute value. And then this is less than delta, and then greater than 0. Then we are going to check absolute value function minus the limit. So we have square root of 3x minus 2 minus 4. Cool. Now for this right here, do the conjugate business again. So this right here equals square root of 3x minus 2 minus 4, multiply the top and bottom by square root of 3x minus 2 plus 4. And then do the same on the bottom as well, square root of 3x minus 2 and then plus 4. Cool. Now multiply out the top, we just get absolute value. It's just 3x minus 2 and then minus 4 squared, which is 16. And then the bottom we just keep it, so it's over square root, there we go, I like to have a space between a square root and a solar fraction part, 3x minus 2 and then plus 4. Cool. Now let's do more algebra. First though, we see that minus 2 minus 16 is minus 18, and then we can factor out 3. So on the top here, we can have 3 absolute value, and then it's x minus 6. Okay, and then same idea like earlier, it's an absolute value of the top and then absolute value of the bottom, but the bottom is always positive, so we don't need the absolute value. So we can just say square root of 3x minus 2 and then plus 4. And what can we do? What can we say next? Well, we can just get rid of the bottom part and say this right here is less than 3 times the absolute value of x minus 6. Why? Because we will mention that square root of 3x minus 2 plus 4 is greater than 1, right? That's what you have to mention. You don't mention this is greater than 0. You mention this is greater than 1. From here to here, we mention it's greater than 0 because we can get rid of the absolute value. But from here to here, we mention this is greater than 1 because we want to have this inequality and then get rid of the whole thing. Cool. Now, we have this, which is excellent. So this right here, it's again another less than thanks to that. And we have the 3 right here. And then we have a delta. And we know it. At the end, we want to have just epsilon. So now, what's the delta? Epsilon over 3. Yes, this is 3 times epsilon over 3. And then we have this and that. Bye-bye. So we come back here and then say delta is equal to epsilon over 3. This is so cool. This is symmetric if you rotate 180 degrees. Yeah, anyway, this is equal, delta is equal to epsilon over 3, and then we are done. We're done. PF, proof, given epsilon greater than 0, and then we are going to choose delta. I don't know yet, but I'm not worried about it. Suppose absolute value x minus 3 is less than delta and then greater than 0 like this. Lastly, we are going to check, and hopefully everything goes smoothly. Absolute value of the function 2x squared plus 1 minus the limit, which is 19. Alright, here we go. This minus that is minus 18, and then we can factor out 2. So this right here is 2. Alright, let's see. Alright, 2x squared. Hold on. Okay. 2x squared. I'll show you guys all the steps. Minus 18. And then we factor out 2. And then we get x squared minus 9. Alright? And perhaps I'll... Yeah, this is okay. And then... Okay. And then this is 2 times x minus 3 times x plus 3. Okay? So, show all the steps. More legitimate. I was going to go from here to here, but now... Yeah, show you guys everything. And from here to here, we use the fact that the absolute value of a product is the product of the absolute value. So, it's pretty clear. So, you can skip that. It's another step. But anyway though, this is nice because we can say that we can have less than 2 times delta. But now, here's the troublesome. Absolute value of x minus 3. How can we get rid of it? Well, how can we get a bound? Meaning that we want to show this right here is less than some number as well, so that we can kind of maintain this inequality so it can go smoothly. How do we do it though? Okay, this is where the magic is. We are going to come back to the delta, come back here right now, and then put down minimum, and then like this notation, like set notation, and then just use 1. Keep in mind, just use 1. Oh, I heard, can you use 2? Can you use 17? Sure, up to you. If you want to have a smooth experience, then I highly recommend you to use 1. If you want to have some adventures, use pi, use 1 over e. Just use 1, please. The moment that we have the 1 right here, we are allowed to come here and say, because delta, we have this 1 that we can use. So look at this inequality, just this side, and we can say absolute value of x minus 3 is less than this number that we put down earlier. we put down 1, so we can use 1. We put down 1 over e, you use 1 over e. You want to put down square root of 17, square root of 17, up to you. Now, from here, we are going to somehow get an expression for absolute value of x plus 3. To do so, one systematic way is just you first open the absolute value, so we will know that when we do that, we get absolute value, we get x minus 3. This right here will be in between of 1 and negative 1. Right? That's how absolute value works, right? If this is less than 1, then that means the inside is in between of negative 1 and 1. And now you see, we want to have x plus 3. This is x minus 3. So let's just go ahead and add 6 to everybody. And this is of course legitimate because this is just a regular inequality. And then you see this is 5. And then this is x plus 3. And then this is 7. Okay? Now, question for you guys. I want to go from here back to the absolute value. How do we do it? Well, here's the idea. Just compare the absolute value of this number and that number, which one is bigger. 7 has a bigger absolute value, so it's just absolute value of x plus 3. Absolute value of x plus 3 is less than this number, the bigger absolute value. Why? Because when we have this, of course, x plus 3, if it's greater than 5, it has to be greater than negative 7. So you see that we have negative 7 also 7, so of course we can write this as absolute value of x plus 3 less than 7. Yeah. And later you are going to see a slightly strange case, but for now, just remember, look at which number has a bigger absolute value. So you know what? Now you see we have this absolute value of x plus 3 is less than 7. This is great because this is less than, we have less than already. We don't have to write it again. This is not a list. You can just say that this right here is less than 7. Yay. Yay, seriously. Okay, now question. What should delta be though? Because again, at the very end, we want to have this to be just delta. So we just want to have this as just epsilon. So what should delta be? 2 times 7 is, I wanted to say 17. 2 times 7 is 14. So we better have delta to be epsilon over 14. So that, you see, 2 times 7, this, and that will cancel. Now, delta we said is epsilon over 14. We come back here and then we put down epsilon over 14. Close this. Right here though, we do not put down equal sign because we say delta is the minimum of 1 or epsilon over 3. So it's a minimum. We want this right here to be less than or equal to, because delta is less than this or that. Okay, we're done. So here we go. PF. Let's go ahead and say given epsilon greater than 0, and then suppose delta is equal to something. Then, no. Given choose. Sorry, I'm tired. Choose. Suppose, here we go. Absolute value of x minus negative 2, so it becomes plus 2, is less than delta, and then this is greater than 0. And then we want to check absolute value, function minus the limit, so x squared minus 3x, and then minus 10. Oh my god, look at this. How beautiful is this? This is a quadratic trinomial. We can factor it the usual way. Okay, we need x minus 5 times x plus 2. So that's the factoring. So here we go. We have absolute value of x minus 5. Let's put on x plus 2 first. Okay, this right here is less than delta. That's nice. Now, we have to get a bound for absolute value of x minus 5. You know the deal. Come here and write down minimal. Put on 1. Just use 1, please. Alright. Come here, just this side, just this part. So we can say this right here gives us absolute value of x plus 2 is less than 1. and we want to somehow go from here to here. So let's open the absolute value. That means x plus 2 is in between of -1 and 1. We want to get to -5. So that's minus 7. Minus 7 here, minus 7 here, minus 7 here, right? So in the middle, we have x minus 5. This right here is -8. And then I'm just subtracting so the inequalities maintain the same. And then less than 1 minus 7 is -6. Hey, this is crazy because if we have the absolute value of x minus 5, this is negative, that's negative. I cannot say this is less than -6. That doesn't make sense. This doesn't make sense. But the deal is that, remember what I told you guys earlier? We are looking at which number has a bigger absolute value. I'm not talking about which number is bigger. So I'm telling you guys that, hey, just do absolute value of x minus 5. Put that as less than the absolute value of -8, which is just an 8. Why is this true? Because here, if you open this, we get what? X minus 5 is in between of -8 and +8. -6 is right here. Of course, this covers that situation. Alright? So, here we have it. This blue part is this. We can just say, hey, multiply that by 8. That's my delta. That's my 8. At the end, we want to end up with epsilon. So delta should be equal to what? Epsilon over 8. Yes. Let me just write it down nicer for you guys. Times 8. Cancel, cancel. Come back here. Epsilon over 8. Close that, make it legitimate. And then right here, less than or equal to, because we use the minimum. So this is how you write the proof for it. Given epsilon greater than 0, choose delta, I don't know yet. Suppose absolute value of x minus 2 is less than delta, and put this, check absolute value function minus the limit. Alright, here we go. Algebra work. This is the difference of two squares. This is the same as 2 to the third power. So we can factor this as absolute value of x minus 2 times absolute value of x minus 2 times x squared plus 2 times x, which is just 2x. And lastly, we add 2 squared, which is 4. Cool. What's this? This is good. Yeah, less than delta. Everybody likes it. What's that? Don't worry. Come back to the delta part, and then we just say minimum. Let's use 1. Okay, starting right here. Let's draw this a little bit longer because of that. Okay, so we're looking at absolute value of x minus 2 is less than 1. For here, we want to get to x squared part, so it's a little bit tricky, so pay attention right here. But the idea is the same. If you can get a bound for this, then you are in good shape. Anyway, open this. So we get x minus 2 is in between of -1 and 1. And for this particular case, I'm going to just, because I cannot get to x squared, right, unless I square everybody. No, let's not do that. Let's just add 2 to everybody. You'll see why. So they cancel. And then we see this is 1, this is x, and this is 3. And then just like what we did earlier, we can say absolute value of x is less than 3. Then you pick the bigger absolute value, which is this. Now, here is the deal. We have this condition. Thanks to that, and we want to see this. So I will just tell you guys that, notice from here and there, we are going to make a connection. When we have the absolute value of x squared plus 2x plus 3, it's plus 4. You see how we have the absolute value of the sum. This right here is going to be guaranteed less than or equal to the absolute value of the first, plus the absolute value of the second, plus the absolute value of the third. Yeah, so this is like the extended version of the so-called triangle inequality. So let me just write it down somewhere. By triangle inequality. Let me give you guys an example real quick. Suppose you have an absolute value. Let's say we have 5 plus 3. Well, is this less than or equal to absolute value of 5 plus absolute value of 3? Yes, in fact, they are equal because it's 8. It's actually equal to 8. But if you have, let's say, this, because you don't know if x is negative or not, I don't know, right? So let's say if we have 5 plus negative 3, I'm going to put the 3 right here and make it negative 3. You see, here we actually just get 2, but then here we have 8. The right hand side is bigger. So again, when we have absolute value of a sum, this right here is less than or equal to the sum of the absolute values. This is the so-called triangle inequality. Because once we have this, check this out. I'm going to use equal sign because this is equal to absolute value of x. This right here is equal to absolute value of x squared. We can put a square on the outside. And the reason for that is absolute value of x squared is equal to absolute value of x times x. And per our discussion earlier, the absolute value of a product is the product of the absolute value. So this is the same as. It depends if you guys have seen this kind of proof or not in your class. Hopefully you can just go from here to here. But anyway, it's this equal sign. And then you can put a 2 on the outside, so it's plus 2 absolute value of x. And then absolute value of 4 is just 4. So from here to here, it's just straightforward equal sign. Now, we know absolute value of x is less than 3. So we can replace the real absolute value with less than. And then 3 square plus 2 times 3. And then plus 4. And then from here to here, it's going to be equal sign because it's just computation. And let's see, this is 9 plus 6 plus 4. So 19. So all in all, we are saying that this absolute value expression is less than 19, which is exactly what we want. This is less than 19. At the end, we want epsilon. Delta shall be epsilon over 19. That way, when we multiply by 19, they cancel. So we can come back here and say, we also needed epsilon over 19. And close this, less than or equal to. Finally, don't you ever forget the box shading. Well, it's super easy, huh? 1 over 2. Let's take a look at the proof of it. Here we go. PF. Okay, given epsilon greater than 0, choose, I don't know yet, leave it. Suppose we have the absolute value of x minus 2 is less than delta and then greater than 0. Then hopefully we can get the absolute value to work for this. We want the function minus the limit. Now let's do the algebra for this. Get the common denominator. We get absolute value of 2 minus x over 2x. Okay. Flip the subtraction so we can use that legitimately. So on the top, this right here is the same as negative x minus 2, right? And then I can take the absolute value on the top and then the absolute value of 2x. Yeah, and then let's see, I'm going to write this down right here. The negative in the absolute value becomes positive, so it doesn't matter, so we just have absolute value of x minus 2 times 1 over, put a 2 on the outside, and then we have the absolute value of x. This right here, we know is less than delta. Excellent. But we don't know what this is. 1 over 2 absolute value of x. So you know the deal. We're going to come here and say delta is equal to the minimum and then we say 1. That way, we can utilize this inequality, just this part. Absolute value of x minus 2 is less than 1. And we want to get this expression, huh? So hopefully you can find this right here to be less than something. That's the goal. We want this to be less than something. Okay, open this. Absolute value of x minus. This means x minus 2 is in between of negative 1 and 1. And then just add 2 to everybody. X is in between of 1 and 3. This means absolute value of x is less than 3. Right? That's what we have done so far. And in fact, I picked the same number like the previous one on purpose. Because that's what we did earlier, huh? And now, we have absolute value of x is less than 3. We want to get 1 over absolute value of x. So shall we just do the reciprocal right now? Well, if we do that, keep in mind both sides are positive. So when we do the reciprocal on both sides, we have 1 over absolute value of x and then 1 over 3. But we will have to switch the inequality. Yeah, for example, we know 2 is less than 3. But if we do the reciprocal on both sides, in fact, 1/2 is actually bigger than 1 over 3. Ah, man. This is so bad because we cannot proceed. We really want to see this right here is less than something. But now we have 1 over absolute value of x is greater than something. No good. So, what do? I'm so stuck. No, don't worry. The trick is that you do not do the absolute value right here, right now. In fact, we actually do the reciprocal first, and everything will go smoothly. Check this out. Everything's positive, so do the reciprocal. 1 over 1 is still 1, and here we have 1 over x, and this is 1 over 3. And then flip the inequalities, right? This. Do the reciprocals first, and then take the absolute value. Absolute value of 1 over x is just 1 over absolute value of x. That should be clear. And now which one has a bigger absolute value? 1. So in fact, this right here is less than 1. Yeah. And then might as well just put a 2 right there as well. Right? It's 2 on the bottom though, so let's multiply both sides by 2. So 1 over 2 absolute value of x. This right here is less than 1/2. This, and we have the less than already. Very good. We know this right here is less than 1/2. So, what do we need for the delta? This one is rather special, huh? We want the delta to be 2 epsilon, because this way, when we multiply by 1 over 2, the 2 and 2 will cancel. So, hurry up. Let's put delta to be 2 epsilon here, and then close this, and then it's a minimum zone. And then finally, draw the box, shade this in. PF. First, given delta, given epsilon greater than 0, then choose delta, I don't know yet. Then suppose absolute value of this minus that, so x minus 1 is less than delta and then greater than 0. Then we want to check. Okay, absolute value, function minus the limit, so we have 1 over 2x minus 1, 2x plus 1 minus 1 over 3. Right. Now let's just get the common denominator, all the good stuff. So just put it down right here, maybe we need more space. Okay, so 3 right here, minus, right, and then I'll just distribute, so minus 2x and then minus 1. Okay, and then on the bottom, I'm just going to write it as 3 times 2x plus 1. Yeah, something like this. Hopefully you guys are okay with it. Absolute value. Alright, okay, 3 minus 1 is 2, and then we can factor out negative 2, so this right here becomes absolute value negative 2, and then this is negative 2x plus 2, yeah? So when we factor out a negative 2, this becomes x minus 1. Yeah, so far so good. We see that, huh? And then the bottom is just that. I can't really do too much, huh? So I'm just going to keep it as that. So 2x plus 1. Now, break this apart. Absolute value of the top and the absolute value of the 2, just the negative 2, just 2, right? So we have 2 and the absolute value and then x minus 1. Okay? And then we have this on the bottom. Put the 3 on the outside. So 1 over 3. And then absolute value of this, 2x plus 1. Alright. So that's the algebra that we have so far. You know the deal. Come here. Minimum 1.7. No, please don't do that. Here, let's see. Look at absolute value of x minus 1 is less than 1. Open it, we get x minus 1. It's in between of 1 here, and then put negative 1 here, and then just add 1 to everybody. So we see that's 0, and then that's x, and then oh, I'm trying to get to there, huh? But let's do the things that we did earlier. 2. Okay, fine. I need a 2x, so let's multiply everybody by 2. So multiply by 2, multiply by 2, multiply by 2. So 2x is in between of 0 and then 4. And then let's add 1 to everybody. So yeah, add 1, add 1, add 1. Things like this. Pretty cool, I would say. So we have 2x plus 1. It's in between of 1 and 5. What did we do earlier? We take the reciprocal first, right? So we take the reciprocal. This is going to be 1 over 1, which is 1, and flip 1 over 2x plus 1, and then flip, and then also reciprocal that. Which one has a bigger absolute value? This does. So this means 1 over 2x plus 1 in the absolute value is less than 1. Really interesting, huh? Because we saw the 1 earlier too. Yeah, and we want the street right there, huh? So let's just say that, to have enough space, 1 over 3 absolute value 2x plus 1 is less than 1/3. Okay. All right. This thing, we have the lesson. 2 is still 2. This is less than delta. I forgot to say that earlier. I was too excited to work out that. All right, and this thing, let me just do like purple. There. It's less than 1 over 3. So multiply this and then we get 1 over 3. Now, ladies and gentlemen, all the way at the end, we want to end up with epsilon. So what should we pick for delta? We better have a delta, we better have an epsilon here, right? We divided by 3, so we better multiply by 3. We multiply by 2 here, so we should divide it by 2. And when we have that, we can see 2 and 2 cancel, 3 and 3 cancel, and we'll just end up with epsilon. And delta is equal to that, so we will come here and put down 3 over 2 epsilon, and then hurry up, let's close this. And then put down, and then yes.